Hello, everybody, and welcome to this Studying Chemistry at University talk. My name is Dr. Simon Gerrard. I'm the undergraduate admissions tutor for the Department of Chemistry at Imperial College London, and I'm really pleased to be able to talk to you today about what kind of things you might be looking for at university, what kind of options are there, what study opportunities are there, and what things might you be looking for researching when you're choosing where to go and which course to choose. Thanks to everyone joining us today. Thank you to those of you who came to our outreach event up at our White City campus previously. I'm really pleased to be able to talk to you today. So let's start the presentation. And I wanted to introduce a little bit about myself to start with, but I'll then go into some details to give you advice about what to look for if you're thinking of studying chemistry at university. But it's not just chemistry. So if any of you are interested in other related subjects or other sciences as well, you can apply quite a lot of what I'm talking about to those other subjects as well. So there's lots of other information and advice here that's applicable to lots of students, whatever sort of science related subject you might wish to study at university. Okay, so hopefully this is showing for you now, the screen. Fantastic. Okay, so studying chemistry at university. Hopefully this is going to be a nice, interesting talk for you. And I wanted to give you a chance to ask questions as well. So we have an online chat, Q&A panel where you can post your questions to us. Answered to answer at the end of the talk. So please do post these for me, and I'll be happy to answer as many as possible in the session today. So, studying chemistry at university, what does it involve? Well, I studied chemistry at university. I did a few things. This was me at 17 years old. I studied A levels, chemistry, maths, physics, and music. And for any of you who are interested in music, I learned the piano and trombone as well at school. I went to study degree, 4-year degree, an MSci degree in chemistry at Bristol. I did a year in industry, working at GlaxoSmithKline in asthma drug development. And after that, I went to move to Southampton to start a PhD. I did a PhD and then a number of years of postdoctoral research in DNA chemistry. And so focusing on gene therapy, nanotechnology, using DNA as a building block, but also investigating different methods of genetic analysis. After that, essentially, I moved into a teaching only role. I've been teaching a little anyway since 2011. And my teaching, both in Southampton and then at Imperial College, where I moved in 2018, has been in medicinal chemistry, biological chemistry, environmental and analytical chemistry as well. So quite varied in that respect. And I've been a teaching fellow in various roles and admissions tutor and outreach coordinator as well in different places. So that's just a little bit about me. Been at university for a very long time, but lots and lots of things to think about there. And I'm interested to find out more about you. So have a look at this. There may be some similarities to things you might want to do in the future, and you may have done some similar A levels as well. So chemistry itself, why is chemistry so fascinating? You might have heard your teachers talk about it as the interdisciplinary science, genuinely links together all the sciences. So chemistry links strongly with medicine. If you're thinking about also what's happening in terms of developing drugs, developing therapies, perhaps medical diagnostics such as MRI and other types of imaging. Really, chemistry helps you to develop these. Chemistry is really essential in helping to design and optimize new drugs and other exciting therapies for particular diseases, and also understanding how diseases work. Chemistry links strongly to physics. So if you want to find out really what's happening in terms of chemistry in the stars, astrochemistry, where you're looking at the structure of the atom, really at this sort of nanoscopic scale is where chemistry and physics overlap. So lots of chemistry students, some chemistry courses will involve quantum mechanics as well. There might be study in terms of nanotechnology, nanomaterials, and computer science plays a big role here as well. Chemistry links strongly to biology. If you want to understand how disease works, how the body works, you need to understand the chemistry within the cell. And as such, chemistry of biological systems is really, really important. It helps you to understand microbiology, biology, how your body's immune system works, and hormones and everything else. Chemistry also links strong to earth sciences. So there are people going out taking samples, might be looking at the chemistry of rocks, of the gas bubbles trapped in ice cores. It might be taking sort of sampling from fields, from water supplies, and looking at sort of forensic analysis of pollutants and other contaminants. So chemistry really links all of these different subjects together. And as such, this is why I find chemistry so fascinating. And hopefully one of the reasons why you find chemistry so fascinating as well. So have a think about what you enjoy most about chemistry. Have a think about what sort of worldwide issues you most care about or most concern you. And where do you think chemistry can make a really significant impact? I don't know whether you've seen this before. This is the United Nations Sustainable Development Goals, the Agenda for Sustainable Development. These are the 17 goals that have been set, and there are many, many projects associated with each of these. These ones are where chemistry has been determined to be able to make a really significant positive global impact. So genuinely studying this subject, going into researching and what are other careers and studies based on this subject, you would be able to make a really significant global impact potentially, or an impact in areas in which you might be interested in, or in issues, worldwide issues that you care about. So let's think about one more detail about what you could do with chemistry. So what applications are there? Well, let's say after studying chemistry at university, you might want to continue research at a university or some kind of research institute. And many, many students do continue their studies in chemistry or related subjects. You might decide you want to work in the chemical industry, and it's more than just pharmaceutical science. You might be interested in developing new types of materials and catalysts. You might be interested in analytical techniques, working in environmental forensics. Perhaps you want to be helping in sort of development of new and better sustainable energies. Perhaps you're interested in coding, programming, but particularly with the increasing developments in AI. It could be that you're interested in additives, coatings, and the whole sort of field which links to materials, alloys, transportation, and other areas as well. You might want to go into teaching. You may want to do first sort of training in teaching afterwards and use your chemistry through teaching at college or university or school. You might even want to use your chemistry skills and the other skills you develop during a chemistry degree in other areas, so perhaps non-chemistry, maybe other science-related areas, or maybe outside the sciences as part of your employment or further study. And I'll be talking sort of at the end of this talk about sort of where students go with a chemistry degree. What do they do after their degree? So what courses are available? There are many, many different courses available, and as such, it can be quite difficult to know where to start. So with over 600 higher education courses with chemistry offered across 95 different universities in the UK, many, many choices are available to you. You might decide you want to do a single honours course. So this is, say, a BSc or an MSci in chemistry, and this is just a degree in chemistry in which you can make various choices in terms of optional modules and studies. You might want to combine chemistry with another subject, chemistry with degrees or chemistry and degrees. There aren't so many chemistry and degrees now, but there are many chemistry with degrees, and I'll talk about how those work shortly. You might want to consider placement options. It might be a year in industry, or it might be some kind of academic placement where you're doing a mixture of research and study at another university in another country. You might be thinking, well, what do I choose? Do I choose a 3-year BSc course, or do I choose a 4-year MChem or MSci course? So the terms MChem and MSci are used interchangeably now. They represent a master's course or an integrated master's course, a 4-year degree, where your fourth and final year is taught at master's level. Okay. So the MSci or MChem degrees, these integrated master's courses, are certainly increasingly popular for students studying chemistry if you want to go into PhD afterwards, if you want to continue your research at university, or for a career in the chemical industry. Some universities are unable to accept students doing a PhD if they have a BSc in chemistry. You'd need to do an additional 1 year MRes or MSc course first. But many universities do accept students with a BSc in chemistry. BSc or MSci or MChem do sort of have an influence in terms of where you might start, for example, if you move into working with a company, and also salaries and things at the beginning as well. There are often, not always, but there are often differences in sort of typical entry requirements between the integrated master's courses and the BSc course in chemistry. Those are some sort of typical entry requirements you might see at some of the top universities in the country. You might be interested in studying natural sciences. If, for example, you're interested in applying to Cambridge, you can only study natural sciences. You would specialise in, say, chemistry or another subject later on. There are many, many courses offered at over nearly 50 universities in the country, and the entry requirements tend to be higher than for other science subjects themselves. So just to give you an illustration, there's a sort of typical range you might see on the screen there. So lots of different things to consider: single versus combined honours, placement options, 3 or a 4-year degree, and the natural sciences. So I wanted to talk now about single versus joint honours. And on the right-hand side of the screen are all the degree programs in chemistry we offer at Imperial College, just to give you an example and an idea about what things are available. So we have chemistry with management, medicinal chemistry, molecular physics as combined honours or joint honours degrees, so chemistry with degrees. And there are many, many different chemistry with degrees offered around the country, with medicinal sciences, business management, maths, computing, education, sustainability, and with a foundation year as well. Foundation years are available to students from outside the country who may not have the right qualifications. They're also available to students who may not have the grades they're looking for a particular course, and so they could start a foundation year, which has a lower grade requirement. And using the foundation year, they would then be able to move into the course of their choice at that university, or sometimes at other universities as well. There are also many, many more specialist degrees. So in terms of chemistry, it might be environmental chemistry or medicinal chemistry or drug design. You might be interested in biochemistry as a separate subject, very, very popular. You might be interested in something quite specialist like pharmacology or pharmacy. Or it might be you're considering chemical engineering, which is rather different to a chemistry degree. Chemical engineering has a lot of maths and a lot of applied physics as part of the course, much less chemistry than some students may realise as part of that. It's taught to help students progress to specific industries. Chemistry is much broader, more theoretical, but still is applied when you're considering research and also studying in later years. So if you're thinking about chemistry versus chemical engineering, do get in touch with different universities to ask about the differences. Do your research online, because there are some significant differences between the two. Entry criteria and the applications process, the admissions process does differ quite significantly across different universities and different chemistry departments across the country, although the UCAS regulations are the same. So typically you may encounter anything from A star A to AAB or ABB or BBB requirements across many different universities. They do vary quite a lot. Some chemistry degrees do require maths. We do require maths at Imperial College, for example. Some may require other requirements depending on the nature of the with subject. For example, say chemistry with maths at a particular university would probably require maths, and our chemistry with molecular physics degree, for example, requires physics as well. There's some sort of typical points requirement for students studying the International Baccalaureate, but many universities across the country will accept a whole range of different qualifications from all around the world as well. So it's best to get in touch with them and check on their website for information. Universities or chemistry departments may have 500 applications, 1,000 applications, or many, many more applications from students from the UK, from across Europe or overseas. They may again have other subject requirements as well. And the level of competition does vary quite a lot between different departments. There are deadlines to draw your attention to. So if you're interested in applying to Oxford or Cambridge for chemistry or natural sciences, or you're interested in applying for medicine, for example, the deadline is the 15th of October this year, 2024. And for all other courses and universities, the deadline is the 29th of January, 2025. Okay, it's called the Equal Opportunities Deadline. If you're choosing your firm and insurance choice, for the majority of students, and this will be made clear to you, the deadline for choosing is the 4th of June, and the A-level results released next year will be the 14th of August. So there are lots of different things to consider as part of the process, and you would all need to write a personal statement. I'll talk to you shortly a bit more about that. It's really needs to be an honest, really constructive representation of you. I'll talk in much more detail shortly. In terms of offers and how they're made, you might be made an offer based on your application form. And so this might be reviewed by a panel of people or a couple of people who might then decide on what offer they wish to make. You might be invited to visit for an informal interview, and they may require you to visit them first before they confirm any offer afterwards. It's a chance for them to get to meet you and you to get to meet them as well and to ask lots of questions. You might be invited for a formal interview. We do that at Imperial College, for example, and where universities or where departments of chemistry, for example, invite students for a formal interview, they will use the feedback from that interview as part of the process, so to help inform their offer-making decision process. So it can be quite varied in terms of what different universities and different departments are looking for and how they do it. So do contact them for more information if you're unclear. Many universities also have a standard English language requirement, often for all students, sometimes not for all students, and often they may require a B at GCSE or IGCSE or a 5 or a 6. Do contact them as well for details, because they will also be able to accept a wide range of other qualifications or tests as well. So what do we look for in a personal statement? As an admissions tutor who's read well over 9,000 personal statements in the last few years, I wanted to give you a few things that we're looking for in a personal statement. So wherever you apply to, whatever you apply to, do discuss your interests in chemistry or the subject of your choice. Discuss where it started for you, to talk about what engages you. What books do you read? Not necessarily because your teachers tell you to, but because you actively want to. Okay. What books do you read? What magazines do you read? What events have you been? What podcasts do you listen to? What social media channels are you interested in? What YouTube channels do you watch? So talk about these different things that have engaged you and what interests you about them, because that in itself demonstrates your passion for the subject without using the words "I am passionate about." Don't forget other issues, other things you might be interested in. So if you watch the news, think about what other global issues might interest you, might concern you, and think about where you can apply chemistry and how chemistry could help. This goes back to that slide a few slides ago. Really, this gives us an understanding that you have at least a little bit of an understanding what you can do with your chemistry degree afterwards. Don't forget your other subjects, though, particularly if you're applying for a chemistry with degree. Don't forget the second subject. But talk about, importantly, how your subjects link together. So where are their overlaps? Why do you have an interest in another subject, say physics, for example, and how does it link to chemistry, and where is your interest in that link? But also don't forget about your other hobbies and interests. If you're applying to Oxford and Cambridge, they may not focus on this part as much detail as other universities. So you might need to also be quite selective in what you include because of the character limit for your personal statement. But do talk about your hobbies and interests. But most importantly, rather than listing your interests and listing what things you've won or things you've achieved, talk about what skills you've gained as a result of these. Talk about what you've learned from them. Talk about how they've helped you, because that in itself tells us a lot about you as an individual. Because after all, this reflection on you, this is important for telling us about you as a person. After all, this is meant to be a personal statement. I will also note that you may have heard this through your school, that for students applying for entry in 2026, so those of you applying in the application cycle 2025 to 26, so in a year's time, the personal statement will be changing to be based on 3 questions. And so do contact your teachers about this. They should have lots of information. It's available on the UCAS website about what these questions are. You still have a character limit overall for answering these questions, but it's much more structured now, which should help give students much better guidance in terms of what to include for different universities. So have a think now about what's important to you. You may have not started looking for universities yet. You might have started to consider some of the things that might be important to you. Perhaps you've considered the reputation of the university. That might be of importance to you. It might be something that you're looking at. It might be something you see via sort of online media. It might be someone who's recommended it to you. You can sort of assess the reputation in many ways. What about facilities? How are the facilities? The facilities for teaching, your teaching labs, for example, the facilities in which you might be doing your research projects. What are they like? What are the teaching facilities like? How much space do you have to study? What are the computing facilities like? It's really helpful to visit if you can, just to see what that is, or do your research online. League tables. They might be helpful for you. They might be useful guide. They might be something you use a little bit at the beginning to help structure your research, but otherwise you may consider them only of general interest or general use. What about distance from home? You might want to be very close to home. You might want to live at home, for example, to start with. You might want to commute, or you might want to be as far away from home as possible. It's entirely up to you. That's a significant factor for some students. Do you want to be in a big city, or do you want to be in the countryside? So many universities do differ. They might be embedded within a city, or you might have a campus of something in a much more rural setting, or a smaller city or a smaller town. Cost of living, very important. It might be that cost of living is a driving force for your decision on where you want to go. Or a campus or in a town. So some universities are embedded within a town, for example. They may not have a particular campus layout, but they're actually buildings within the town's layout itself, or they might be on a separate campus, a campus which might include your halls of residence. It might be a campus where the halls of residence are outside the campus. So this is something you might want to consider as well. You might want to think about contact hours. Essentially, contact hours, so scheduled time in your calendar, tends to be very much higher for science subjects. You could expect to get anything up to 26 hours a week, but it depends on whether you might have labs happening in that week or not. So this is something that you might want to ask questions about. Accommodation, particularly important. It might be that the accommodation is quite expensive, or it might be cheaper. You might want to think about what type of accommodation you're looking for. Are you looking for a flat? Are you looking for a room in a shared sort of house? Perhaps you're looking at ensuite or not ensuite. Maybe you are happy to share with someone, or if you prefer to have a single room. These are things to consider. You want to be able to study or work abroad. So many universities and chemistry sort of courses have the option to study abroad or do a placement. It might be a research placement. It might be an industry placement. It gives you an opportunity to experience a different country, a different culture, a different sort of area of science, perhaps, that might be available at the university where you study. The atmosphere. Something that's difficult to gauge just by looking. It's best to try and visit if you can, to get a feel for the atmosphere and whether it feels the right place for you to study and work in and be in for 3 to 5 years. Student support. So student support, particularly important. You might want to sort of ask questions about what support options are available to you, what you can do, and what support you might wish to discuss if, for example, you've had support arrangements at school. So lots of things to think about there. A few more things you might want to consider as well. Once you've started looking already, once you're trying to reduce your sort of selection of choices, you might want to consider what other subjects you can choose alongside your degree as optional modules, electives or ancillary modules. You might want to think about the ability to transfer between different degree programs, different courses. So tends to be rather common, particularly in the first year, but also in the second year in some cases as well. You might want to think about what topics are available for you to study in your later years of the degree. So this is something that you can look at to see if there's anything of interest to you. You might want to consider the nature of the research that the department does and the industrial opportunities available. So what kind of placements you could do. You might want to think about the placement programs. How do they work? And also, how does the department or the university help you to develop your skills? What about the teaching, the facilities, the research places that you'll be in? But also, what other opportunities are there as well to develop your experience, to Uh, Build your skills to explore areas of science outside your degree, perhaps to get involved in public engagement, in prototyping, in coding, or whatever it might be. And also think about employment statistics. So the graduate outcome survey, where do students go to? What kind of careers or further study do they do after completing their degree? This is something to have a look at. Each university will have its particular statistics that you can look into detail at if you wish. So what modules in chemistry could you experience when you're studying your degree? You might have core chemistry courses. So across all years, you might cover things such as mass spectrometry, NMR, different types of spectroscopic analysis, electrochemistry, sort of related to batteries. You'll be covering the structure of the atom, thermodynamics, some quantum mechanics to talk about structure and bonding. You might be looking at modeling of molecular of orbitals. You might be looking at the synthesis of compounds. You might have optional modules you can choose or elective courses that you can choose alongside. So you may want to be studying medicinal chemistry, perhaps, or nanotechnology. Perhaps you want to be exploring material science. Perhaps you maybe want to be looking at renewable energy alongside your chemistry degree. You might also have the option of choosing non-chemistry courses to study alongside your chemistry degree. Could be molecular biology, maybe engineering. Perhaps you want to study business. Perhaps you maybe want to learn a language alongside your degree. Many options are available. And laboratory. Do you talk to different departments, wherever you might be interested in applying, about what individual laboratory work you might have? Maybe is it work in pairs? Is it individual? Could be do they do group project work? Find out about the nature of the lab work that you could be involved in. What happens in terms of assessment? Well, it's very varied indeed. It's not just closed book exams. Assessments could be formative, in which case you're given feedback, or they could be summative, in which case they're marked and contribute towards a degree. You could have closed book or even open book exams where you could bring notes in. You might be asked to give presentations. You might be asked to give a talk about your research. Perhaps you're doing tests in lectures. You might be given some tutorials or worksheets to complete. You might be doing multiple choice questions. You might be assessed in your lab book on writing risk assessments. There are many different types of assessment for particular different skill sets and also for different modules that you will encounter at university. In university, many students will have a research project in their final year of some kind of research investigation. And this gives you a chance to sort of carry out really cutting edge research alongside research scientists, PhD students, gives you really fantastic opportunities for networking and talking to other people and getting advice about your next steps. You might be considering placements, industry, or in other universities in other countries as well. Many different opportunities are available, and different universities and different departments will have slightly different ways in which these are arranged or in which they're allocated and selected. And do take opportunities as well. Talk to people, talk to universities about what outreach you can get involved with, what internships and other summer placements and competitions they might have available. You could be involved in outreach, helping to inspire a younger generation of students to want to do chemistry and other sciences. So also have a think about where can we find this information? So lots of things you can ask, you can talk to universities directly, but where else can you look? You could check out the Discover Uni website. This gives you information about or sort of feedback from students across the country about all different courses at all universities. You can do comparisons on there to compare different factors. A really valuable place to look. Talk to your family, talk to your friends, your teachers, your careers advisors. They give you all useful, very useful information. But do talk to more than one person just to get a broader sort of understanding and outlook. Do check the UCAS website. This gives details about all the different courses that are available and the minimum or the typical entry requirements for each. You can also look at the grades on entry tool as well. This is something that was introduced this year. It's a tool very useful for seeing what grades students have actually been accepted on their courses, but do be aware it may not account for all grade profiles that students have entered their courses on. Do check out brochures, prospectuses, websites, do your research through that, and try and visit universities wherever you can, really to get to ask questions of students and staff and to get a feel for the location and the facilities that you can use. Do check online and other sources. So you might want to go through student unions of universities. You might want to check out UniBuddy or other networks and forums such as the Student Room for advice. So developing your skills as a chemist. During your degree, what can you encounter? What might be involved? Well, practical lab skills. Chemistry is a very practical subject indeed. So you might be carrying out synthesis of molecules. You'll be analyzing what you've made. You might be designing experiments, optimizing experiments, designing equipment, and learning how it works. It gives you a chance as well, studying chemistry, to apply your knowledge and to problem solve, to link topics across different modules, to apply what you've been learning in the lab, applying the chemistry you've been learning to the experiment that you're doing. But also not just applying the chemistry concepts, but applying mathematics and statistics in chemistry. There's a lot of applied mathematics, for example, in quantum mechanics, in doing molecular simulations, in spectroscopic analysis, and analyzing your data as well. Many chemistry courses they're increasingly involving programming, significant data analysis, computational modeling, and coding as part of their degree. Or you might have options to do that as an optional module, for example. It's becoming particularly important and particularly valuable to employers, particularly with the development of AI as well. And so you might see something like this on the screen as part of a chemistry module, or perhaps a different module that you could take alongside your chemistry degree. You'll have practice in scientific writing, writing your lab notebook, keeping reports, writing a review of, say, literature, perhaps doing some research into what's been published and known already, in how to present your own analytical data, how to write up and present your own work as well. So talking about presenting, I was talking about presenting in terms of writing. Now let's talk about presenting in terms of verbally and graphically. So thinking maybe creating a poster or a PowerPoint presentation or something like that. How do you communicate results? How do you discuss results? And this could be individual or group based. But also your own personal development. And so a chemistry degree or any science degree certainly will give you help in managing your study and helping to build your own personal skills and your professional development. So things such as leadership, building your confidence, helping you in managing your time, helping you in communicating in a concise yet meaningful way, thinking about networking, what career options you might have. Often there'll be training courses or modules and things that you can get involved with to help you in your development. Thinking lastly on graduate prospects. So what do chemistry graduates do after their degree? This is sort of just data from us as an illustration. Many students go off into employment. Many students go off into further study after their degree. It varies quite a lot across the Russell Group of universities, for example, in terms of the proportion, and the proportion varies each year. But this is sort of the last 3 years of available data from the Graduate Outcomes Survey, just to give you a bit of an idea about the split. That happens to be us, but it does vary quite a lot. Chemistry graduates are recruited into nearly every branch of industry. Chemistry joins together so many subjects and overlaps with so many areas that you'll have chemists going into sort of chemical engineering, other engineering, material science, sort of biotechnology, all sorts of different areas. And really, chemistry informs nearly everything we do and can really help tackle significant global challenges. And as such, actually studying a chemistry degree doesn't close off areas to go into. It opens many, many doors, in fact, to a wide range of different areas that you could explore in a future career or future study. So thinking about some of these areas, we've had students going into manufacturing, into sort of information communication systems, into finance, accountancy and banking, many other professional, scientific or technical roles in various companies and other institutions. They may have been going into sort of healthcare. We've had students going into trading and marketing and publishing. It's incredibly varied. And these are just examples of some of the employers that some of our chemistry graduates have gone to. But this is really sort of illustrative of where chemistry graduates might go to from degrees across the country. So it could be into sort of science-related areas, chemistry-specific areas, such as pharmaceutical companies. But students have applied the skills that they learned during their chemistry degree in accountancy companies, in publishing, marketing, finance, in teaching, and various other areas. Students have gone into further study in terms of graduate entry courses in medicine, in law. Students might go into chemical engineering or other areas of further study after a chemistry degree as well. So many, many different options available to you. And in terms of other occupations, we've had students go into sort of analytical science, become research scientists or technical sort of science technicians in schools and colleges. We've had people going into teaching, into consultancy, product development, really, really incredibly varied as well. So a chemistry degree doesn't just lead to chemistry. It doesn't just lead to sort of pharmaceuticals or teaching. It's incredibly varied where you can go as a result of a chemistry degree, but also other science degrees more generally as well. And as such, it really genuinely opens the world really to you in terms of where you could go and research, in further study, in work, not just using the chemistry and scientific sort of skills that you've learned as part of your degree, but using your numeracy, your analytical skills, your ability to search for information, and your communication and presentation skills. You can apply this in a really wide range of areas across industry, across many different careers and further study. So I hope this has been helpful to you. Thank you all very much for watching this talk. I'm very happy to answer any questions now. And I really hope this has been of use to you. Please do get in contact with myself or any other departments. They will be happy to answer your questions about wherever you would like to go and whatever courses they're offering. Thank you.